All right. Well, we are getting Dave Thomas back here. I'm super excited for this talk. Let's code like it's 1969. Dave Thomas is the author of the Pickaxe Ruby book. He's also one of the authors of the Pragmatic Programmer, and he's involved in a lot of the stuff over there at PragProg, so pragprog.com. So I'm excited to hear from him, see what he has to say. All right, go ahead.
Okay, welcome everybody. Greetings from sunny Texas, where it's currently 95 degrees and about 100% humidity. So this is cool. This is also kind of weird. I'm sure other people have said this, but the idea of presenting to nothing is actually kind of funky. So forgive me if I'm a bit stumbly. But anyway, what I'm is to talk about a kind of new form of programming that I'm discovering. And this is a form of programming that actually is not new at all. It's been around for 50 years. And I'm going to do that by showing you some code examples in Elixir. And given that this is a Ruby crowd, I kind of wanted to, first of all, say I love Ruby. I have devoted the last, I don't know, 15, 16 years to Ruby. And I still love it. In fact, I'm coding Ruby this morning, and I was coding Ruby all of yesterday. So Ruby is still a language I love and I use a lot. However, I think the idea of sticking with one language simply because you like it and you're familiar with it is kind of crazy in a world that changes as much as we do. So I'm constantly looking around for new challenges and new languages. And I found that with a language called Elixir. Some of you may be familiar with José Vilim. He's on the Rails core team. And he also produced an initial stab at a version of Ruby that ran on the Erlang virtual machine. Now, Erlang is a language that was designed initially for writing telephone switches in, and since then has branched out. If you happen to be in Europe and you send a text, the chances are something like 75% that your text is going to go through Erlang switching software. The characteristics of Erlang are that it's highly performant, highly reliable. You can do things like hot code swap in it. And Elixir is a language that's built on top of that Erlang virtual machine. Now, this is where I start to get pushback. My belief very strongly is that the future is functional, and obviously the future is concurrent. I mean, we have no option. Moore's law is still kind of accurate to a point, but it doesn't tell the whole story. I mean, if you look at transistor chip counts since, 1970 something, right down the bottom there, the 8008, that was probably the first processor I programmed. And right now my laptop is up here somewhere with just over 1 billion transistors on it. That's just on the processor, the CPU. Just to give you an idea what that's like, okay, that's 1 billion transistors, which still blows my mind every time I talk about that. The actual die size is something like 120 square millimeters, which means that we have 8 and a bit million transistors per square millimeter. And given that the US is still about 400 years behind in terms of the metric system, just to give you an illustration of what a square millimeter looks like, I finally found some use for Clippy. And that is, if you cut the end off, what's left, the little circle there, is about a square millimeter. So we have 8 million transistors a square millimeter, 1 billion transistors on that chip, and our job as programmers is to keep those transistors busy. And clearly, we are not going to be able to do that if we are coding sequentially. And that's where Moore's law is kind of breaking down, because you cannot produce anymore one processor that has, 1 billion transistors on it. The speed of light gets in your way, quantum effects get in your way. So instead, what you have to do is you have to create parallel computers. We call them cores, whatever else. And so we'll be running multiple cores. So I have 4 cores in here. Next year, probably be 16 or 32, 64, 128. So probably within like 3-4 years, we'll be having 1,000 core processors. And when we get to that kind of size, obviously, we are writing concurrent code. If you think about things like the Rails model of computation, every request basically runs single-threaded through a process. Now, that's not going to scale as we become more and more parallel. because you're going to run out of ability to run those processes. So we're looking for better ways to become concurrent. Now, the subtitle to the Elixir book is Functional, Concurrent, Pragmatic, and Fun. And I honestly believe that. And what I want to get to right now is the functional side of that and the fun side of that. So let's start off by saying that all of this is different. And one of the things I found really exciting about playing with Elixir is I'm having to throw away an awful lot of what I believed was, the truth about programming. So I've been doing object-oriented programming now for 30 years. No, more than that, actually, probably closer to 40 years. And, in my head, that's the way you program. And so it's taken me a long time to undo that kind of instinctive way of writing code. And I've really enjoyed that process because it's made me rethink a whole bunch about how I code. So programming in Elixir has changed the way I think about programming, fundamentally. Now, it's changed the way I write Ruby code for the better, but there are things I cannot do in Ruby that I can do in Elixir that I wanted to show you in terms of different thinking. And to give you some background, I want to talk about two things. First of all, the idea of pattern matching, and secondly, the idea of a function. Now, in Elixir, the equal sign is not assignment. It's actually closer to the equal sign that you used to use in high school algebra. So remember in high school algebra, you'd say x equals y plus 2. Now that didn't mean set x to be the value of y plus 2. What that meant was x will consistently be 2 more than y, and that's all it meant. So if you were to write x equals y plus 2 and x equals y times 5, then you could solve that as a simultaneous equation, away you go. So the same thing applies in Elixir. When I write a equals 1, I'm not assigning 1 to a. I am asserting that a and 1 have the same value. And so later on in the code, if I use a, then I can substitute 1 for that value because I know that a and 1 have the same value. In the next line of code there, I have a tuple. That's with the curly braces around it. So that's like a kind of fixed length list. And here I'm saying that I have a tuple that has C and D in it, and that is the same as a tuple that has 2 and 3 in it. And to make that true, then Elixir says, okay, well, in that case, C must be the same as the value 2, and D must be the same as the value 3. I can also match on a list. So that's the square brackets, and the same thing applies. So E, F, and G equals 4, 5, and 6. The next line is a pattern match, but it's using string concatenation. That's what that kind of diamond operator in the middle there is. So it's saying that the string Elixir concatenated to something is the same as Elixir rocks. So therefore, that something has to be rocks. And therefore, for the rest of the code, rest will have that value rocks. And last but by no means least, how do you match a list that has a variable, an unknown number of values in it? Because the example on line 3 there is always going to match a 3-element list. Okay, it says EFG, it has to have 3 elements. Well, I'm going to do that by dividing the list into a head and a tail. The head is the first element, the tail is the rest. And the operator to do that is that pipe. So if I say head, pipe, tail inside a list, then the head will be matched with the 1, and the tail will be matched with 2, 3, 4, 5, 6, etc., etc. And by doing that, I can decompose my list one element at a time. Let's go back a bit there, sorry. You can also do pattern matching inside regular code. So here I have an Elixir case statement. Now, a file.open is going to go an open operating system file, and it's going to return a tuple. By convention, the first element of the tuple is some kind of status, and then the second or subsequent elements are the data. So if I open a file and it opens successfully, then file.open returns OK, and then the actual device that you're going to be using, and that's a tuple. So here in my case statement, I'm going to match on whatever file open returns. If it's OK and then a device, well, it's going to match the second thing, the device, into that variable device, and therefore I can know an io.read on that device to read the next line from the file. If I don't get that, then I'll get an error. And if I get an error, the next parameter will be the reason code, and then I can output some meaningful error message. I can also apply pattern matching to function definitions. So here, for example, there are an anonymous function, that's the code between the fn and the end, and that function actually has what they call heads, 2 function heads. The first one, the parameters are plus a and b, and the second function head, the parameters are times a and b. So if I call my anonymous function, as I do down the bottom there, with plus 3 and 4, then the first head is going to match, and it's going to execute the code a plus b. If instead I call it with times 3 and 4, then the second head matches, and it's going to run a times b. So this is pattern matching. You can also do the same thing when you define named functions, and that's kind of looks a bit funky because this, you might think I'm defining multiple functions here. I'm not. I'm actually defining one function that has 2 separate function heads, and Elixir will choose to run the appropriate function depending on the parameters that I pass to it. At this point, you may be thinking, wow, that's going to be really slow because it actually is going to be sitting there searching through all these function heads to try and find a match. Actually, it is unbelievably fast. The Erlang virtual machine is designed to do this, and it has some very clever compile time and runtime optimizations that mean that this selection here is actually faster than just about anything else in the language. To give you an example, the Unicode conversion in Elixir is actually done by having, I think it's something like 24,000 function heads for the same function that match various combinations of binary characters. And it runs really, really, really fast. Okay, so pattern matching is matched on the shape and the content. So that by the shape, I mean, is it a list, is it a scalar, is it a tuple? And the content, obviously, is the actual values inside there. We can use it to destructure data, and if you want to, it can be recursive, which means you can have destructuring inside destructuring. All right, so let's see some of this in action. And this is all kind of leading up to my revelation in programming. So we'll start off with the simple stuff. So if you go to Wikipedia or something like that, then you will see the definition of Fibonacci is something like this. There's a kind of like a whole bunch of controversies to whether fib 0 is 0 or 1. That makes it really exciting. But fundamentally, fib 0 is 0, fib 1 is 1, and fib n is n minus 1, n minus 2. If you're going to code that in Elixir, you could write this, def module fib, and then the same function, fib, with 3 different heads. The first one is going to match if you pass it a 0. The second one is going to match if you pass it a 1. And the third one is going to match if you pass it something else. So if you pass it a 0, then it's going to return 0. If you pass it a 1, it's going to return 1. Anything else, it's going to return fib n minus 1 plus fib n minus 2. So if you call put as fib 10, I don't know, that's 55, I'm not too sure. But whatever. You can see how that's going to work. Already you can see that this is pretty elegant. There are actually a number of different ways of writing that. You could do it like this. You could also do it in a single function like this. So here I have my same def fib. It's going to get called a number of times, but I'm going to do the selection inside a case statement inside the function. And possibly, if you were coming to this from another language, you might write it like this. Now, you have 3 different ways of writing Fibonacci. I think probably, if you looked at the original specification in Wikipedia or whatever, then this way is probably the one that matches the best. And so I would probably write it this way simply because it looks like the spec. Now, when you stop and think about it, that is incredibly cool, right? Because the program actually reflects the specification directly. And then inside that program, we have functions. And all a function does is take an input and produce an output. That's all a function is. And in this case, our functions are showing the transformation of data as the program executes. So the shape of the program reflects the specification, and the implementation reflects the transformations. And to me, that is a fundamental aspect of programming. And I'm learning more and more that that is the significant thing. And that is, I need to think of my programs in terms of transformations and then matching the circumstances in which I want those transformations to take place. Another example, the length of a list. The length of an empty list is 0. This is just kind of like part of the specification. The length of a list with a head and a tail is, well, 1 for the head, and then whatever the length of the tail is. So it's 1 plus the length of the tail. And again, if you wanted to express this in Elixir, the program reflects the specification. The length of the empty list is 0. The length of a list that has a head and a tail is 1 plus the length of the tail. And that just works. One small thing here, I've used a convention on the second function head there. I use underscore head. Elixir checks for unused variables at compile time. And by putting an underscore in front, I say, don't bother, this is just like, I'm just giving this a name, but it's never actually used. Okay, one last boring example, and maybe I'll make a fool of myself and do some live coding. So here we have a specification of map, just like Ruby's map. So if I apply a function to an empty list using map, then the result is an empty list. There's nothing to apply it to. Otherwise, it's going to map the head and then apply map to the tail. So I get a new list whose head is the function called on the original head and whose tail is the map of the tail. And again, the implementation looks exactly the same as the spec. So the map of an empty list with a function is the empty list. The map of a non-empty list with the function is, well, I'm going to apply the function to the head and then append the map of applying the function to the tail. So that's all pretty cool. So let's actually look at some real code here. So a slightly more practical example. Back in the day when memory came by the byte, not by the gigabyte, we used to worry a lot about the size of data. And there's a technique called RunLength Encoding, which is still used quite a lot to reduce the size of a list if it's likely that there are duplicate values in the list. So here you can see I have a list 1, 2, 2, 2, 3, 4, 4, 5, 6, 6, 6, 6. And I can reduce its length by taking runs of the same value and replacing it by the value and a count. So here I can say I have a 1, 2 3s, sorry, 3 2s, a 3, 2 4s, a 5, and 4 6s. So I want to write a program that does that. So at this point, I want you to stop, or I'm going to stop, and I just want you to think for a second about how you would code that up in Ruby. And I want you to think a little bit about the edge conditions. What happens if the run starts on the first character of the list? What happens if it ends on the last element of the list? All those kind of things. I can pretty much guarantee that if I was to code this program, it's about 50-50 that I will bump into some edge case that I hadn't thought of, and I'll have to go back and fix it. So this is a really great example of something that actually lends itself really well to this transformational style of programming. So what I'm going to do is I'm going to start off with my input list and my output list. So if you like, this represents the state of my program. I have everything in the input, nothing in the output. So now what I'm going to do is I'm going to look at my input and output, and I'm going to say, okay, I have a 1 at the start of my input, nothing in the output, so all I can do is copy that 1 down to the output. So now I have a 2 at the start and a 1 in my list. Again, nothing I can really do. I'm just going to copy my 2 down. And for various technical reasons, I'm going to reverse my output list. So now I'm looking at a 2 at the front of my input list and a 2 at the front of my output list. So now I know what I need to do is to change my output to say I now have 2 2s. Again, I'm looking at a 2 at the front of my input list, and now I have, logically, a 2 at the end of my output list as well. So I need to change that from 2 2 to 2 3. The 3 doesn't match anything, so it just goes down. The 4 doesn't match, it goes down. But now I'm going to start doing the same thing again. So this is the way I want to look at my program. It's a transformation from input to output based on sort of logical patterns. All right. So you can look at it a bit like this. If the input is empty, then our result is finished. Okay, we've actually got the values. If our input is A and our result currently has an A at the head of it, then we're going to replace that result with A2. If our input is A and our current result has a tuple an, we're going to replace that with the tuple an plus 1. Otherwise, we're just going to copy that input to the head of the output list. All right, so let's go code that up and see what happens. So, where are we? Let's go to Emacs here. Okay. So, with Elixir, I'm going to create a brand new project. Elixir comes with a tool called Mix, which is a little bit like Rake. So I'm going to say mix new RLE, that's RunLength Encode, and that's going to construct a project for me called RLE. So if I go down into RLE, oops, sorry. Now if you have a look, I have a README, a config, a lib. There's my equivalent of my rake file, my mix.ex file, and a test directory. All right. Inside lib, this is very familiar if you've been doing Ruby. You'll find that there is a top-level RLE file, and then typically for more complex programs, you'll create subdirectories inside lib. So let's start off by editing that lib rle.ex file. Okay, and there's an empty module that was constructed by Mix, and that's just our empty RLE program. So we're going to write a method, a function, sorry. Let's call it encode, and it takes a list. Okay, now, there's a cool thing I can do here. Obviously, we're going to write comments for our code, and Elixir, as well as having normal comments, allows me to write documentation comments. These are interpreted to be marked down and play nicely with all various help tools and IDEs and things. So, for example, here I'm going to say that our encode method takes a list and replaces adjacent duplicate values with a count and the value. Okay. Now, I don't know about you, but I like to see comments that actually show examples of this thing in use. So I'm going to do this. I'm going to say IEX, which is the equivalent of IRB. So if I was to say rle.encode, let's start simple. Start with the empty list. Okay. What I'm expecting to get back is an empty list. All right. So let's save that away. Uh-oh. When I saved it, it automatically ran my tests. Now, what tests, you might say? Well, let me see. Have a look here. It says test doc at rle.encode. What this is saying is, as well as running regular tests, which would be in that test directory, it's also going to look at my documentation and extract out from that any samples that I have and run those as well. So here it ran the sample RLE code, passing in an empty list, and expected to get an empty list back. But what actually got back was nil. So my tests failed. And you'll notice down the bottom here, my Elixir is now in red background to say, hey, guess what? You got failing tests. So let's fix this. Now, I'm going to skip a step because I know that whenever I'm dealing with state and results, I am going to have to introduce a new parameter which is going to hold my result. So I'm going to make my encode immediately call a helper method here. I'm going to call it _encode, and it takes a list and the result. And currently our result is going to be the empty list. Oh, sorry, I didn't mean to do def there. I want to just do encode. Okay. And now I have to define my encode method. I'll use defp because it's private. And what am I going to do? Well, the first case I want to deal with is when I'm past the empty list. So if I'm past an empty list, I currently have a result. Well, then I know that my result is going to be whatever's in that result variable. So I can just say do result. And this should deal with our initial case here. So if I run my code again, yeah, now you'll notice my Elixir has turned green and I have no failures. So let's give ourselves another case. Let's give ourselves the case. Okay. Nope. let's pass in 1, 2, 3. So what I expect to get out of here is 1, 2, 3. Actually, let's make it simple. Let's just do 1 to start with. So if I run this, well, I'm going to get a different kind of failure here. Okay. What's happened here is that I have something called a function clause error, because there is no function clause matching in encode or underscore encode. What's that mean? Well, the only definition of underscore encode I've got here has got a open square bracket, close bracket, empty list, but I'm passing in a non-empty list. So let's have a separate case here. Def p. So let's say I'm passing in a non-empty list. Okay. Well, a non-empty list has a head and a tail, and I still have my result variable here. So what I need to do is basically copy the head onto the result. So initially, I'm just going to return head followed by result. So if I call that, my test passed now. I've got a single entry. So now let's make it more complicated. So now 1, 2, 3, and this is going to fail because I'm not taking the case I want to have more than, once I found the first entry, I'm going to return the result and not do anything else. So what I actually have to do is to take the head, and that's my new result, and I'm going to say underscore encode the tail, because that's my new input, and the concatenation of the head and the result, that's my new result. Now if I run this, it's going to be better, but it's still not quite going to work, because you'll notice now that my left-hand side over here is 3, 2, 1. And that's because I keep putting the head at the beginning of the result, not the end of the result. So what I actually have to do over here is actually reverse my list. And to do that, I can say enum.reverse encode the list. And now my test passed. Okay, so I have my basic test of the non-duplicated lists working here. So let's do a little bit more. Let's add some duplication. So let's go 1, 1, 1, 2, 3. And what I'm hoping to get out of here is the tuple 1 followed by 3. Sorry, 3 1s followed by 2 followed by 3. And that's not going to work because it's not handling duplication at the moment. All it's going to do is to take the list and copy it. Actually, you know what? Just to make life a bit easier, I'm just going to go with 2 at the beginning here to start with. So now I need to deal with this case where I'm going to copy the first one into the result, but then I need to notice that the second one is the same as the head of the result. And this is where it gets really fun. So if I say def p, so now I have an input list that contains a head and a tail, and my result also starts with the head. Now notice this. Remember we said that the assignment isn't assignment, it's just asserting that 2 values are the same. And this is just like algebra. Well, here I've done the same thing. I've said that because that h has been matched to whatever's the head of the input list, then that h in the result has to be that same value. So if I match a 1 in the input list, there has to be a 1 at the head of the result list. So if I have a 1 at the beginning of both lists, then what I'm going to do is I'm going to replace my result. Sorry, I'm missing a. Yeah. I'm going to replace my result with one of those tuples. So I'm going to have to call encode again, and this time I'm going to encode the tail, and my result is going to be the tuple of h and 2 followed by the rest. All right, does that work? Oops. Oh, I didn't actually change my documentation up here. And that's kind of cool, actually. The fact that it does check your documentation for you means that your examples in your code are always going to be right. And there we have it. So one more thing to do, and that's that case I had before. And that is I'll have 1, 1, 1, 2, 3. And now I'm expecting it to have a 3 there. And this isn't going to work. And this isn't going to work because it handles the case where the head of the list is the same, the head of the result is the same as the head of the input. But here what I'm going to have is, after I've done that once, I have 1, 2 at the head of my result. I then try to match that 1 and it doesn't match. So I need one more case in here. And that case is going to be when I have a H at the beginning of my input and I have an HN at the head of my result. And then I need to replace that HN with HN plus 1. So run that. Test pass. Now let's just do, just like a slightly different case. Let's do 3, 3, 3, 3. Why not? So now I'm expecting 1, 2, and then there should be 4 3s there. Cool. All right. So you can see here that what I've done is I've just taken each case I need to think about and just matched it. And when I match it, the code just works. Now, can we do better than that? Yeah, we can. What we can do is we can say all of these things here look pretty much the same, right? All I'm doing is I'm taking my input and my output, I'm producing, my input and my result, I'm producing a new result based on that. So can I code that slightly differently? Yeah, I can. Let's code this as a simple loop where what I'm going to look at is my I'm sorry, I just had a total absolute brain fart. So in my loop, I'm going to write myself a loop that goes through the list one element at a time. And so I'm going to be picking out the head of the list, and now I'm going to have the result. And the result I'm always going to be looking at is going to be the head of the result. So I'll just call that A for now. And the tail of the result. Let's call that rest, just to make it slightly clearer. Okay. So for each one of those heads that's going to come through, right, I'm going to have some special cases. So the first case I've got is if the head is the same as, so here, it's this case here. So if the head is the head and the A, so if the head is H, well, let's call it V, and the tail, you know what, I'm just totally spacing this out. Let's forget that. Let's forget that. All right, come back to our slides for a second. So what I coded there was the kind of linear version. But here we have a slightly different version of it. It's exactly the same code, but I've written it in a different way. So what I've done is I've taken my encode method, the underscore encode method, and I've actually wrapped it into a single function rather than having 4 separate function heads. And I've actually just used a case statement inside it to look at the next variable of the list and then the current result. And you'll see that I have exactly the same pattern matches there as I had in the original functions, but in this particular case, it's all kind of wrapped into one function. Now to drive that, what I need to do is to take each element of my original input list and pass it in turn to my encode function. And I also need to keep track of the result. And to do that, well, I have reduce exactly the same as I have for Ruby, which basically takes a value and a state and then invokes a function on it. So here, the value is going to be each character in turn. The state starts off as an empty list, and the function I'm calling is underscore encode. The /2 there means this is the version of underscore encode that takes 2 parameters. And finally, when I've got that finished, I need to reverse the result. And you'll notice in my top encode method there, I'm using this pipe arrow thing. This actually is a pipe operator, and what it does is it basically takes the value on its left-hand side and injects it as the first parameter in the value on the right-hand side. So this is effectively the same as saying, take my list and pass it as the first parameter to a num.reduce, and then pass in the list and the encode method, and then pass the value there as the parameter to a num.reverse. So here what you can see is transformations. This is not new technology, and hence the 1969 business, because all of this goes back to the 1960s. Decision tables are simply a way of, given a set of rules, you look up what to do next. State machines are simply a way of representing how to process state. So here, for example, if I wanted to write a state machine that compacts spaces in a string, so replaces multiple spaces with one, my start state is going to be I'm copying data from the input to the output. If it's a non-space character, I'm going to continue copying. If I get a space, I'm going to go into a new state, the space scene state. In space scene, if I keep getting spaces, I'm just going to stay in that space scene state. Otherwise, I'm going to go back up to copying if I have a non-space. And here's where it gets cool, because associated with each of those arrows, each of those transitions, I can add a function. So here I can say, whenever I'm in the copying state and I see a non-space, I'm going to copy that to the output. If I see a space, I'm going to copy it. But now, when I'm in space scene, I'm going to ignore spaces. And then finally, if I get a non-space when I'm in space scene, I'm going to copy it back up again. So this is a state machine, but it's annotated with functions. And if you'd like, you could call those functions transformations. So this is what I'm doing here in this RLE method. I have transformations. The encode method is a transformation. It takes a list and it produces the RunLength encoded list. And here I have a state machine. I have an event, which is the next element of the list, and then the state, which is the current result. And I have transitions that do pattern matching. So basically, I'm traversing based on the state and the event. So it's just like a state machine. And all I'm doing is I am creating a new value for the state based on the event and the state. This is the kind of key to this way of thinking. It's very, very different to thinking just as linear code. All I do is I think to myself, what are the possible states I could get into, and what do I want to happen in each of those states? And you'll notice that when I was coding that program originally, it just kind of fell out. I didn't have to think too hard about it because I only have to think one state at a time. All right, so enough of me pontificating here. If you think about a functional language with pattern matching, then the pattern matches are the rules in the state machine, and each match that you do represents a transformation of state. And when you execute that transformation, you can do so with the application of functions. And so basically, the transformation of state, you actually run a function almost as a side effect of that. And that kind of totally inverts the way we normally think about coding. Normally, we think about functions as being the thing that cause state to change. Here, it's the state change that's causing the functions to run. So we've seen some examples of that. Okay, here we have a simple state machine, all right? But we can actually write it slightly differently. So rather than actually having all the logic in one function, I can say, to read a line, I'm going to call my helper method, and the state I'm going to pass it is the result of opening the file. And now I'm going to do two pattern matches. One is going to say, if the state is OK in a device, then I'm going to read a line from that device. Otherwise, I'm going to come back with nil. So you notice here, it's really the same code, but I'm just thinking about it differently. I'm thinking about it as pattern matches and transformations. Here's an example from the Elixir code itself. This is the code that loads the .iex file. This is kind of like an initialization file for IEX that you can customize. So the rule is that if I pass it a path for that file, then that's the one it has to use. Otherwise, it's going to look for a .iex.exs file in your current directory or in your home directory. It then looks to see which of these files actually exists, and if it finds one, it's going to evaluate it. And this code works fine, looks great. It's kind of like the way you'd write it in Ruby. But to my mind, there's way too much in one method, and it's kind of like not clear. So as an experiment, I rewrote it like this. So the top-level function there, load.iex file, simply says take a path. From that path, derive the possible IEX files. From those, find the first one that exists, and then update the config based on that. So here's a statement of what I want to do, and it's just a little spec. Now I'm getting into state machines and pattern matching. To get a possible IEX file, if I don't pass in a config, so if it's nil, then I'm going to give the default list, IEX and the 2 IEX files there. Otherwise, I'm just going to return that path as a list. Then I'm going to say, okay, now find the first one that exists of those. So I'm going to take my paths and pass them through in num.find until I find one that's a regular file. And that's going to come back up and then go to my update config. The first parameter is going to be the first that exists, and the second parameter is the config I pass in. Again, a little mini state machine, 2-line state machine that says if I don't have a file that matches, then just return the original config. Otherwise, I'm going to update the config based on the contents of that path. This works on the big scale too. So let's imagine we had a REST service and we were handling some kind of merchanting site, and we have to be able to get special offers for the user. So maybe what we're looking at is something like a Living Social or something like that, right? So we're going to identify our user. We're going to find local offers, it's like the donut shop down the road. Find national offers, like you can get 20% off tires. And then merge those two results and respond back to the user. Now, this is a concurrent thing because I want to be able to go and find the local offers and the national offers at the same time in parallel. Now, surprisingly, you can actually express this very simply using exactly the same thing as a state machine. But here we have two things happening in parallel. We look up the user, and then in parallel, we're going to find local offers, find national offers, and then when both of those are finished, we're going to format the response. And we could do it, this is kind of like an abstraction of the state machine, but we can do that by just using these kind of states. So initially I have this percent squiggly bracket. This is a map, it's a bit like a Ruby hash. So it starts off, my state is get offers, and I have authorization. And whenever I match that in my state, well, what I want to do is to go and find the user from that authorization. So my result from this is another map that has the same get offers thing in it, but now I'm going to add into it user and then the user from authorization. Now I've got a new state. If that state is the user is nil because we didn't actually do the authorization, then all we have to do is to respond, not authorize, and then we're done. Otherwise, if we have a user, now we're going to do two async calls, async get local offers, async get national offers. These are going to fill in the state as they go along. So now we're back here. If the user, so that should actually typo, that should be user colon user. If our national thing returns an error, it's going to populate the state with national error. So if we get an error on the national side, we're going to respond with an error. Similarly, if we get an error on the local side, we're going to respond with an error. Otherwise, but at this point, we now have a user, we have the national response, we have a local response, so we're going to format the response and send it back to the user. Now, obviously, there's a little bit of hand waving in there, but the situation actually works. I've tried it. And this is very cool because now I can just express everything as states. Think how much easier this is going to be to test, because all I have to do is to test individual state transitions. So I'm going to enter a particular circumstance and make sure that my system responds appropriately. So I think this is really interesting. It is easy to make parallel. I think that you can view the state machine as a DSL to represent business flow. And you could actually probably build a higher level DSL around that. You get very, very granular reuse because everything is simply match some state, go to the next thing. So you can have reuse all over the place. Obviously, testing gets easier because you just inject a state and you see what the system does. And you can get some very cool error handling. I haven't illustrated that here, but because you actually know the states, and if you wanted to, you can keep track of the state transitions, you can actually do the same kind of error handling that a compiler does. And say how you got into the circumstance and why. So I'm saying that this is a different way of thinking. It's not new, it's ancient, but it's still a new application of it. And I think this is really exciting, and so this is how I'm spending my time at the moment. Once you start thinking differently, you'll find yourself programming differently. And I'm finding myself doing a lot more state-based things in every language I use. So I think that the advent of languages such as Elixir is an opportunity for us. I think it's one of those kind of paradigm changes that comes along fairly rarely. And I think that we need to start thinking about thinking differently. We don't want to sit there and create yet another Rails replacement. And Phoenix for Elixir is not another Rails replacement. We need to think about the world differently, and we need to use this opportunity to start coding differently. And I think if we do, we'll have a whole bunch more fun. So, sorry, I meant to. So I'd like to finish that off with a quote from the Princess Bride. You killed my programming paradigm. Well, let's not prepare to die. Let's prepare to have some fun. Cool. All right. So where are we? Okay. So where do we have any time? Yeah, we have a few minutes. So should we take some questions?
Yeah, let's do some questions. Go ahead and type them into the chat. The question that I have that's most obvious to me is, as we move toward the future that you're kind of laying out, where does that leave Ruby?
I don't think it does too much to Ruby. I guess the first question I've got is, why do you care? In the same way that, for example, when Ruby came along, people would say, well, where does this leave COBOL, or where does this leave Java, or whatever else? Ruby is a tool. It's a wonderful tool. It's a tool that I adore using, and I will still use. You know, if I have like a database-backed website I need to create, then Rails is the obvious thing to create it in, or Sinatra, or whatever. And there is nothing I know that's more effective than that. But if I wanted to produce something that was, say, web services based with WebSockets talking to clients and everything else, then no, you know what? I think Elixir is actually a better bet. I can handle far greater concurrency with far higher performance. So I would go Elixir for that. So these are simply tools. Now, the problem with tools is that you tend to fall in love with the tool that you know the best, and you tend to use that to the exclusion of others. And what I'm doing here is I'm trying to say, okay, yes, we all love Ruby. Yes, this is our most comfortable place to be. However, I think we also need to think about what's going to come down the road, you know. And in the same way that Ruby kind of like took over from a whole bunch of other languages when it came to doing a certain kind of web app, I think you'll find that Elixir and things like Elixir will show us a new way of developing, you know, the next generation of those kind of apps. And eventually something else will come along that's better than Elixir, and you know, so it will go. And that's exactly as it should be. What I'm hoping is that the brains that are behind the Ruby community will also get behind this and start coming up with all these very cool things that you can do in Elixir. So what does it leave Ruby? It leaves Ruby as Ruby, you know, and it doesn't actually change anything. It's just another opportunity for us as developers to have fun.
All right. Well, I'll go read some of these questions out of the chat. The first question is the Baba asks, handling nil here seems to be a lot more elegant. Do you think rethinking our avoidance of nils is in order?
Yeah, well, okay, so nil is simply yet another value. And in pattern matching, it's fairly normal to think about nil as a special case. Having said that, you'd be surprised at how often you don't use nil in Elixir. There are a few cans, like for example, when I returned that a nil if I couldn't find the file, I mean, that was just really to show the code. You probably wouldn't do that in practice. The other thing that I didn't show you is the philosophy of dying early. So in Erlang and Elixir, the idea is that if you cannot pattern match something, then you don't sit there have a catch-all case that says, you know, io.put as, oh, I couldn't handle this, what should I do? You know, no, you deliberately do not write a pattern to match those cases. And as a result, you'll get a runtime error. You saw that happen when I had that list and I got the runtime error. The idea is that your program is supposed to crash. And then what happens is that when you're writing anything other than a trivial program, it will be written in something called a supervision tree. And a supervision tree will pick up the fact that a small component of the program has crashed, and it will either restart it or decide that that crash now means that something else has to go down. And because of that, it's kind of a weird way of thinking about it, but because of that, you'll find that Elixir and the Erlang programs are actually incredibly reliable, simply because they crash. If you look at some of those telephone software, they claim 9 nines availability. And a large part of that is because that they are resilient to failure. Another large part of that is that it supports live code reading, live code reloading, so that every module that I write, you notice that RLE was a module, I can take that module and inject it into a running system and then control the migration of its use from the old one to the new one. All right.
Our next question. Oh.
Should I just read through them?
Yeah, go ahead.
All right. Is it fair to say the granularity specification in combination with doc test is programmable? Not necessarily. If I'm writing unit tests, then I may well be writing unit tests down at a slightly lower level than that. The code that I wrote there didn't have the need for lower level unit tests. So yes, the doc test gave me what I was looking for in unit tests. But if I was going to write something that had a way more functionality down at the state transition level, then I'd probably write unit tests for those individual transitions, but they would not be exposed on the public API, so I wouldn't have them in the doc test comments. How much library support is there for functional languages like Elixir? You would be amazed. And the reason is that Elixir is bytecode compatible with Erlang in the same way that Scala and Clojure are bytecode compatible with Java. And as a result, all of the Erlang libraries are available. And there's also the ability to access native code. So typically you'll find what you need. Now, what you won't find is the things like the active merchant gem. Not yet, anyway. And that's because to date, the code that we've been writing in Erlang has not been kind of like e-commerce type code. So that is a definite hole, but it will get filled in. Okay. Are pipes in Elixir lazy? Actually, well, yes and no. Pipes are not directly lazy. However, enumerable or enum has a cousin called stream, and you can switch back and forth between them. Stream is lazy. So, for example, I could have written that RLE thing, and if rather than using enum, I'd use stream, then I would be able to run length encode an infinite input stream and produce results, just basically shoot them out as I needed to. And pattern matching for HTTP handlers, you're absolutely right. I mean, and that is actually a really good example of using the pattern matching. The thing that I want to get across, though, is that pattern matching applies to more than just, obvious pattern matching. It actually applies to state transitions, and it applies to regular business logic as well. And it looks like I've just blown through my time. I apologize, Charles.
No, it's fine. We have a break after this, so.
Oh, okay.
So the other question I have is there a framework for web development in Elixir, sort of like Rails?
Oh yeah. There is a fantastic framework called Phoenix. Phoenix is kind of like, how would I express it? It's not on Rails as much as, it's like halfway between Sinatra and Rails. But what it has is it's rethought the way it thinks about events, basically. So that in Phoenix, I can write code that handles HTTP requests, I can handle WebSocket requests, I can handle JSON, I can handle all of these things in a kind of very transparent manner. And then it's taken it a step further. So there's an event mechanism built into it, and I can generate events either on a client or a server, and they become visible on everything, the client and the server. So if a client wants to raise an event, a server can actually handle it, and vice versa. So it's great for writing just regular old boring database type applications. Supports PostgreSQL, a few others in the back end, has templating, everything else. But if you want to take it a step further and have your applications be more dynamic, then you can also use the WebSocket support and literally migrate code back and forth and migrate events back and forth. It's very, very cool. What are the most common uses for Elixir? Right now, server-side, switching code, code that has to handle large numbers of connections, code that has high throughput. Excuse me, quite a few game servers are beginning to be written in Elixir, both for dedicated games and also for, like in-browser type games. The classic example of that is there's a German online poker site that uses an Elixir backend. Switching software, testing software. Some people are using Elixir to front-end existing Rails applications so that they can use Elixir to do specialized caching or request normalization before it passes it onto the Rails side. So basically, whenever you have a high-demand system with lots of stuff going on, then you want to think about Elixir. The other thing it's really great for is just in terms of the number of requests you can handle through Phoenix, for example. Recently, Chris McCord benchmarked, I think it was 200,000 or 400,000 requests a second through a single box, an EC2 box, using Elixir. And he's compared that to Rails, and fundamentally it comes back to that thing I said at the beginning, the Moore's Law thing. And that is that with Elixir, you are not running, you're not relying on sequential execution through a core. Right? You just have, on my laptop here, I can create 4 million processes, 4 million Elixir processes. And each of those has an independent state, independent execution. And I can create those 4 million processes in about 5 seconds. So it's designed for that kind of high concurrency. And if Amazon starts shipping 1,000 core machines, you'll be using all 1,000 cores automatically. There won't be any code you have to change.
All right. Well, I think we've gotten all the questions out. Really, really interesting talk. So thanks for coming, Dave.
Hey, my pleasure.
And yeah, now I have one more thing I got to go play with.
I know, it's just like, but this is actually, I think, it's one of those things that pays itself back way more than much of the other kind of plays that we do, because I think it does change the way you think. And, anything that does that, I think, is worthwhile.
All right. Well, we're going to go ahead and head into our break. We'll be back at 2:30 Eastern Time, which is in about 25 minutes. So go get some food. I'm going to run downstairs and make a sandwich. And yeah, we'll be back then.
Cool. Bring the sandwich over when you're finished.
Wish I could.
Okay. Take care, everyone.
Yeah, bye.